Welcome dear viewers to the video on discriminatory power of dissolution test method. Many of the videos are there on the Pharma Learning in-depth channel on discriminatory dissolution method and discriminatory power of the dissolution method. But still the topic is vast, topic is very important. That's why I thought to make a video on the same topic again. And I assure you, after watching this video, you will be able to understand the concept of discriminatory dissolution test method and the ways to prove that in the complete sense and in the complete understanding. This video will make you understand and give you much clarity about the ways and techniques and strategies for proving the discriminatory power of the dissolution test method. Discriminatory power is required to be proved and dissolution method should be discriminatory whenever you are developing the formulations. Demonstrating that the dissolution test method and the dissolution test specifications can distinguish between the formulations or distinguish between the batches which are good batches or which are bad batches. Now good batches are those which are in line to the batches which undergone in the clinical studies or the batches which undergone the bioequivalence studies, and bad batches are those the batches which are not meeting the dissolution criteria as per the bioequivalent batches. So the batches with meaningful differences in the drug release rate should be detected by the dissolution method. The dissolution method should detect the quality batches or discriminate the quality batches and the mismanufactured batches. Then in the another way, the dissolution method should detect bioequivalent batches and bioinequivalent batches. So that property or that power of the method is called as discriminatory power or discriminatory ability. So some steps are there to prove the discriminatory power. First is formulation variation. You can work on to the critical material attributes or excipient levels and the process parameters. You can vary those parameters and you can see whether the dissolution method can detect those batches or not. Then test the dissolution test conditions and optimize those test parameters. Then perform dissolution profile comparisons like F2 similarity, ANOVA model independent methods are there. Some statistical methods are there to compare the dissolution profiles. Perform IVIVC. Use stability and stress samples for testing for the dissolution. Test for the robustness and repeatability of the dissolution method. Perform dissolution and compare the reference product or R&D product dissolution with the test product dissolution. Then evaluate the critical quality attributes which affect the dissolution and drug release. Mainly, discriminatory power is required to be shown for all the modified type of formulations. The immediate release formulations which are containing the insoluble APIs and Sometimes it becomes difficult to demonstrate the discriminatory ability of the method when the formulation contains BCS1 or 3 API and when the drug product shows rapid or very rapid drug release or dissolution. So always understand that all the modified release type of formulations should be developed with the aim that you have discriminatory dissolution method. The higher formulations which are containing the insoluble APIs should be tested for dissolution, and the finalized dissolution method, which is QC method, that should be discriminatory, because QC method is going at the plant from R&D, and that method should detect the good batches and the bad batches at plant, so that the bad batches cannot enter into the market. So this was the brief information for the topic. Now see, formulation variations. You can do changes to the formulation composition. You can change the CMAs of the excipients and APIs, and you can change the levels. For example, you can change the binder concentration or the binder viscosity, and then you can check the effect of change in binder onto the dissolution. Then change in the particle size of the API, that is critical material attributes of API. Change in the manufacturing process parameters like compression force, granule size, drying conditions. So these are critical process parameters. Use stress or degraded batches for dissolution testing and see whether the method can detect the changes or not. Expose the samples to heat and humidity or stress samples or stress conditions and perform dissolution. Intentionally manufacture the batches with faster and slower release formulations and see whether these are detected by the dissolution method. Sometimes manufacture the out of specification batches to see whether your dissolution can detect these changes or not. Use of intentionally varied formulations, faster, slower release profiles, manufacturing variations to study the dissolution test method discriminatory ability. One of the most important thing here is that formulation should ideally represent the real world variability, such as what might occur during the manufacturing or stability changes. If you are working onto a formulation manufactured by wet granulation, and if you show that the same formulation manufactured by direct compression is showing the discriminatory ability of the dissolution method, then it will not be a good parameter to show the discriminatory ability, because in the real world you are not going to manufacture that batch with DC process. So finalize your process, finalize the parameters, and then do the meaningful changes to the composition and the process parameters. The meaning of meaningful variations are 10 to 20% variation to the finalized parameter, whether it is concentration level of excipient or the critical process parameter range. You can play with the hardness in case of tablet. You can play with the coating weight gain in case of pellets. So many things are there. Whatever you understand it is critical, then change that in a meaningful way, and it should represent the real world variability, and then perform dissolution testing and see whether it is reflecting into the dissolution or not. Then optimize the dissolution test conditions like agitation speed, pH, so that you can ensure that these are enough to detect the differences in the release profiles. If you are working on to the dissolution for tablet formulation, you are using paddle apparatus and you are developing the method with 75 rpm or 100 rpm paddle speed, then it will be very difficult for you to justify or prove the discriminatory ability of the formulation for the formulation using that dissolution method. The dissolution method test condition should not be giving you the under discriminatory dissolution results. Example is like pH. Different pH media can simulate different physiological environments and can give you the greater discriminatory power. Then coming to the dissolution profile comparisons, F1 F2 comparison can be done using the batches manufactured with the target parameters, target composition, and compare it with the mismanufactured batches. Analysis of variance, ANOVA, multivariate statistical methods are there to assess whether the dissolution method can significantly differentiate between the batches or not. And if there is a statistically significant difference in the dissolution profiles between formulations, it proves that the method has discriminatory power. You can use model independent parameters. You can calculate the mean dissolution time, that is MDT. You can go and test the dissolution efficiency, and then you can provide the proof that dissolution method is having the discriminatory power. Then you can go for IVIVC also. Establish a level A or level B IVIVC correlation between the in vitro dissolution data and the in vivo pharmacokinetic data, and IVIVC will help you to prove that the method can differentiate between the formulations with clinical relevance. So this will help you to justify the dissolution specifications and also the dissolution method's capacity to detect the clinical relevance between the dissolution of some batches. A strong IVIVC indicates that the discriminatory power of the dissolution method translates into the meaningful changes in the bioavailability or therapeutic outcome. Mainly you should consider the percent release versus the AUC and versus the Cmax. Also you can consider Tmax versus the dissolution rate. So IVIVC can give you the good idea. Stability and stress testing. So you can use stress samples to see whether there is any change in the formulation itself and whether your dissolution method can detect the compromised product that have altered release profile due to the aging or due to the environmental stress. Testing of stability sample in comparison to the control sample can give you idea about the discriminatory power of the dissolution method. Detection of the differences in dissolution due to degradation confirms that the method has good discriminatory power. Then testing for the robustness and repeatability. Reproducibility testing involves testing the multiple batches for demonstrating that the discriminatory power is consistent across the replicates. Testing for robustness is done by performing the robustness testing to ensure that slight variation in the dissolution method parameters like agitation speed, medium compositions do not compromise the method's ability to discriminate between the formulations. This ensures that method remains sensitive even when slight changes occur during routine testing. Then coming to the comparison with reference product or RLD or comparator product. So you can compare the test product dissolution profile to the reference product under the same dissolution conditions. The discriminatory power is proven if the method can detect variation between the formulations and the reference product in terms of dissolution profiles. So this can also be done, but always I will recommend that you should compare the bioequivalent batches with the mismanufactured batches, and also check whether your specification time points are specific enough to detect those changes or to detect those parameters or to detect those changes in the percent release or percent drug dissolved between the different batches. Then critical quality attributes evaluate the effect of change in the critical quality attribute effect onto the dissolution. Evaluate whether the method can detect changes in the critical quality attributes that affects dissolution, such as tablet hardness, DT time, percent coating weight gain. Demonstrating that the dissolution method correlates with this CQS proves that it has the discriminatory capability. So, in short, we have discussed regarding the formulation variations, dissolution test condition optimization, dissolution profile comparisons, IVIVC, stability and stress testing, testing for robustness and repeatability, reference product comparison, critical quality attributes evaluation for proving the discriminatory power of the dissolution test method. So this was the video for giving you the information regarding the concept of discriminatory power of dissolution test. So always follow all the guidelines which are related to the dissolution, and you should have the specification which is in line to the regulatory requirements. Do not give too much wide specification or relaxed specification to the formulation. Otherwise, it will be very difficult to justify the specification itself, and also it will be very difficult to justify the dissolution method discriminatory power for that dissolution. For example, if your formulation is IR formulation and it is releasing the API within 10 minutes, like 100% release in the 10 minutes, and if you are giving 80% Q specification at 30 minutes or 45 minutes, then the specification itself is not in line to the regulatory requirements, and also it will lead to difficulty into the discriminatory dissolution method capability. If your formulation is showing rapid release within 10 minutes, so always give the specification of 80Q in 15 minutes, and then you can make some mismanufactured batches. You can use stress samples and perform dissolution, and then you can easily justify or easily provide proof for the discriminatory ability of your dissolution test method. If you are keeping too wide specifications, then it will be difficult to prove discriminatory ability. Also, do not make very stringent dissolution specifications, because if you make much stringent dissolution specification, then many of the good batches can also be rejected. Always consider the dissolution data of biobatches, bioequivalent batches to make the specifications for dissolution. So I think this information is sufficient for the current video. I will make other videos onto the same topic with some new information. I hope you might have got good idea about the topic from this video, and I request you to like, share and subscribe to this channel. Share the videos to your friends and colleagues so that this information can be conveyed to the professionals. Thank you for watching the video, and please stay tuned to this channel. Thank you.